Hello students, myself Mehul from LJIET Institutes of Engineering and Technology. So in last session we start a new chapter, that is Flywheel, and we discuss some important topics of related to Flywheel. So in today's session we are going to learn, that is numerical based on Flywheel. Clear? Okay. So for the understanding numerical based on Flywheel, you have to remember 3 to 4 equation. The equation for the maximum fluctuation of energy, that is delta E. Now you have to understand what is mean speed, what is maximum fluctuation of speed, and what is minimum fluctuation of speed. Clear? Now you all know what is the equation of fluctuation of energy, delta E. There is 3 equation of fluctuation of energy. Clear? First one, delta E is equal to I omega square Cs. Clear? Where I indicate mass moment of inertia, omega indicate angular velocity of the flywheel, and Cs indicate coefficient of fluctuation of speed. Okay. Now second equation for the maximum fluctuation of energy, that is delta E is equal to I omega 1 minus omega 2. Clear? And third equation for the maximum fluctuation of energy, that is delta E is equal to 2E Cs, where E indicate energy of the flywheel. Now flywheel is in rotating motion. Clear? So equation for the rotating motion, that is E is equal to 1 by 2 I omega square. Okay. So now we start to solve one numerical based on flywheel. Clear? So example number 1, there is the turning moment diagram for a Patel engine is drawn to following square. Clear? Now turning moment diagram is a turning moment versus crank angle. Clear? So we have to consider one scale for that. The turning moment 1 mm is equal to 5 Newton into meter. Clear? In turning moment diagram, turning moment indicate the y-axis and crank angle indicate the x-axis. Clear? So for the 1 mm is equal to 5 Newton into meter for scale for the turning moment, and crank angle 1 mm is equal to 1 degree. Clear? The scale for the crank angle is 1 mm is equal to 1 degree. The turning moment diagram repeat itself every half revolution of engine, and the area above and below mean turning moment diagram are. Now you all know the turning moment diagram for the multi-cylinder engine is in the form of sine wave, means we have a continuously one positive circle and one negative circle. Clear? Positive circle or positive cycle indicate flywheel gain some power, and negative cycle indicate we have to deliver some power. You all know this thing. Clear? So area for that is 295 and 685, 40, 340, 916, 270 mm square. All the area we have to cover in mm square. Clear? So this area we have to convert it in the form of Newton into meter based on scale. Clear? The rotating mass are equivalent to a 36 kg. Mass of flywheel is given, that is 36 kg, and radius of gyration small k is given 150 mm. Now you have to convert mm into meter. Clear? So k is equal to 0.15 meter. Determine the coefficient of fluctuation of speed when engine run at 1800 rpm. We have to calculate the coefficient of fluctuation of speed, that is Cs. Clear? And maximum fluctuation of speed or the mean speed given, that is 1800 rpm. Okay. So now we have the equation delta E is equal to I omega square Cs. Based on this equation, we have to calculate the value of Cs. Clear? For the find out the value of Cs, we have to calculate the value of energy, maximum fluctuation of energy, delta E, capital I. Equation of mass moment of inertia, you all know, that is I is equal to mk square. M indicate mass, k indicate radius of gyration. Okay. So now we have to solve this numerical. First of all, we have to derive the given data. So small m is equal to 36 kg, mass given, radius of gyration k is equal to 150 mm. You have to convert it into meter, that is 0.15 meter. Next, capital N indicate mean speed, n is equal to n1 plus n2 by 2. It is the average of maximum and minimum speed of the flywheel. The value of n is equal to 1800 rpm. And based on n, you can calculate the value of omega. You know what is the equation of omega, that is 2 pi n by 60. Put the value of n over here and you can calculate the value of omega, that is 188.52 radian per second. This is the given data. Now we have to solve this numerical. Now in this numerical, there is a 6 area is given, clear, and the turning moment cycle repeat itself after every half revolution. Now first cycle is positive, second is negative, third again positive, fourth negative, fifth positive, and sixth cycle is negative, clear. And you all know positive cycle indicate flywheel gain some power, and negative cycle indicate we have to deliver some power. So in this diagram, based on this diagram, you can understand we have to consider energy at point A, capital A, there is capital E. We have to assume energy at an initial point, at a starting point. So we have to assume energy at point A, that is capital E. Now from A to B, there is one positive cycle is there, and area of that positive cycle, that is 295 mm square. Clear? Means positive cycle indicate flywheel gain some energy, so we have to add this energy in the assumed energy, that is assumed energy is capital E, so we have to add 295 mm square and for the find out the energy at point B. So energy at point B, that is E plus 295. Clear? So based on that, we have to calculate energy at each point, energy at point A, energy at point B, C, D, E, F and G. We have to calculate energy up to at point G. Now for the convert this mm square area, we have to convert this scale into Newton into meter. Clear? So turning moment scale given in the data, that is 1 mm is equal to 5 Newton into meter, and angle for the crank angle, that is 1 mm is equal to 1 degree. Now you have to convert this degree into radian. For the converted any of the value in the radian, you have to multiply pi by 180. Clear? So for the vertical scale, 1 mm is equal to 5 Newton into meter, and for the horizontal scale, 1 mm is equal to pi by 180 radian. Clear? Now area in the form of mm square. Clear? Now you have to multiply x direction scale and y direction scale. So based on that, you can find out 1 mm square is equal to, now you have to 1 mm square on turning moment diagram is equal to 5, that is indicate the vertical axis, into pi by 180, that is indicate the horizontal axis. Clear? You have to multiply these two value, that is pi by 36 Newton into meter. So now we have one relation, 1 mm square is equal to pi by 36 Newton into meter. Clear? Okay. Now we have to calculate energy at each point. Clear? Now energy at point A, that is capital E. Energy at point B, that is E plus 295, because between A and B one positive loop is there. Clear? Now energy at point C, that is E plus 295 minus 685, because between B and C one negative loop is there, so we have to deliver some power or deliver some energy. Clear? So energy at point C, that is E plus 295 minus 685 is equal to E minus 390. Now energy at point D, again we have one positive loop is there, so we have to again add the energy at point D. So energy at point D is equal to E minus 390 plus 40 is equal to E minus 350. Energy at point E, so E minus 350 minus 340, so E minus 690. Okay, so this the energy at point E is the minimum energy for all the point. Clear? Now energy at point F, again one negative loop is there, so E minus 690 plus 960, so answer is E plus 270. And energy at point G, that is E plus 270 minus 270 is equal to E. So energy at point A and energy at point G are same, so then and then your example is correct. Clear? Now you have to identify from all these points at which point we get energy maximum and at which point we get the energy at minimum. So you can identify that energy at point B, E plus 295, that is the highest value. So maximum energy indicate at point B, and E minus 690, energy at point E, that is the minimum energy. So for the find out fluctuation of energy, you have to find out difference between maximum energy and minimum energy. Then and then you can find out the energy difference, maximum fluctuation of energy. Now maximum fluctuation of energy, you all know delta E is equal to E max minus E min. Clear? So you have to find out delta E. Now we know that maximum fluctuation of energy delta E is equal to maximum energy minus minimum energy. So maximum energy is E plus 295 and minimum energy, that is E minus 690. Now you have to simplify this equation and you got the answer, that is 985 mm square. Now we have to convert this mm square value into Newton into meter. For that we already derive one relationship between mm square and Newton into meter. 1 mm square is equal to pi by 36 Newton into meter. So you have to multiply this value with pi by 36. So 985 into pi by 36 is equal to 86 Newton into meter or 86 joule. So this is the answer for the maximum fluctuation of energy delta E. Now in this example we have to calculate value of coefficient of fluctuation of speed, that is Cs. Now we have one equation, delta E is equal to I omega square Cs. Clear? So based on this equation we have to calculate Cs. Now we find out value of delta E. Now we have to calculate value of capital I and value of omega. Based on that you can calculate the value of Cs. Okay, now Cs indicate coefficient of fluctuation of speed. We know that maximum fluctuation of energy delta E is equal to I omega square Cs. Now instead of I you can put mk square, because moment of inertia, equation for the moment of inertia, capital I is equal to mk square. So equation converted in the form of delta E is equal to mk square omega square Cs. Now we have all the value. Now we have only one unknown is there, that is Cs. Clear? Put all the value over here and calculate the value of Cs. So put value of delta E, that is 86 joule, is equal to small m, mass of the flywheel is given, that is 36 kg, into k, that is radius of gyration 0.15, into omega square, we already derived value of omega, that is 188.52, into Cs. Now in this equation we have only one unknown, that is Cs. Now you can calculate the value of Cs, that is 86 upon 28787 is equal to 0.003 or 0.3%. This is the value of coefficient of fluctuation of speed. So in this example we have to calculate the value of energy, value of coefficient of fluctuation of speed, that is 0.003 or in percentage form, that is 0.3%. Clear? So next numerical we discuss in our next lecture.